Alright, hello and welcome to the Demo7 video for demonstrating the extended ALU unit. So here I've got the ALU and my inputs and all my select modes. So let's just go through them real quick. So we've got 7 minus 3 because we're in subtraction mode since select is on 0, should give us 4. 7 plus 3 should give us 10, which it does. 7 times 3 is 21, and if we see here we get 5, and that is the remainder left over from the upper bits. Since this is only a 4-bit output, we're missing that extra 16, and that's what the next mode gives us. So we should have 0, 0, 0, 1 for the next, because that would be the 16 left over from the upper bits that get cut off because of the limitations of our output. Next we have A divided by B, the whole number part. So 7 divided by 3 should be 2 with 1 left over, which is our next mode, the modulus operator. So we could see that that's our remainder of 1 when we divide 7 by 3. Next we've got rotate A left. So let's actually turn this into a binary real quick so we could check it out. So if I rotate this number by 3 to the left, I should take this leftmost bit and see that it travels 1, 2, so 3, excuse me, so it should give us 1, 0, 1, 1, which we could see here. So again, this bit got shifted 1, 2, 3. Next we have shift right. So if we take this bit again and shift right, 1, 2, 3, we should have the others falling into place there. Next we have the bitwise and, so the rest of these will actually be bitwise. So let's actually turn 3 into binary as well. So AND is a masking operator, so only everything that has a 1 should be showing up, which is just the last 2, and that's what we have here. And then bitwise NAND should just be the opposite of that, so we should see 1, 1, 0, 0. Great. Bitwise OR is anything with a 1 should come through, and anything that's a 0 should stay 0, which we've got here. And bitwise NOR should just be the opposite of that. Next, we've got bitwise XOR, which should be any 2 that defer should be a 1, and any 2 that are the same should be 0. So looks like only the bit right after the most significant should stay 1, and everything else should be a 0. Great. Next we have XNOR, which should just be the opposite of this. And then finally we have the bitwise NOTs. So we've got NOT A, so that should be 1, 0, 0, 0. And then finally we have bitwise NOT B, which should be 1, 1, 0, 0. Great, so let's look at the internal of this. So let me zoom out. So here I've broken up each of these components and their muxes into sets of 2. So we have the add and subtract, the multiplies, the shifting or the rotating, the divide and modulus operators, and then the bitwise AND NAND, bitwise OR and NOR, bitwise XOR and bitwise XNOR, and then the NOT A and NOT B's. So I broke them up this way because these top 4, or top 8 if you will, are all arithmetic based operations, and the bottom 8 or bottom 4 units are all bitwise operators. So we could look at some of them. Some of them are just the standard built-in Logisim units. So if we look at add and subtract, we've just got the subtract and addition here. Same with multiply, the shifting, which we did do the shift operations in week 8, so I could have brought those in, but just for simplicity's sake, I use the built-in Logician ones. The division, which has the output and the remainder, and then the 3-bitwise, which these are ones I made. And they have all the standards that you could want. The one thing is that I do break them up into the regular version and the knotted version, with the exception of the last one, which bitwise knots and just cuts off the other one. And so that is all of the internals for it. Having this kind of calculator mode with multiple modes is really nice, because having to go to your add machine that might be on one side of the room, it would be very frustrating to do something there and then run all the way across the room to do the division on a different machine that could divide, and so on and so forth. It's nice having them all together so that you could quickly take whatever inputs you need and quickly get the calculation, and repeatedly do that if you need more than one operation done. So there is the demonstration of the extended ALU. Thank you and have a nice day.